Hello everyone, I'm Srijon Chakraborty. Today our topic is modifiers in Java. What is modifiers? Modifiers are keywords that add to those definitions to change their meaning. So it means that you can add the modifier before the declaration of the class or the variable or a method. For example, you can add public void my method. So it means that the method you would have declared, it's an public. You can also declare this kind of method as a private or protected. For example, in Java there are two types of modifiers: Java access modifier and non-access modifier. It might be make you confused that we all about know the access modifier. What is non-access modifier? We're gonna talk about later. Let's see the access modifiers and then we look through the non-access modifier and so on. So first, see the access modifiers in Java. Java provides a number of access modifiers to set access level for the classes, variables, methods and the constructor. It means that you can set the access level to the user of that class, the variables inside the class, method inside the class and the constructors. So Java provides four types of modifiers. For example, default modifier, private modifier, public modifier and protected modifier. Okay, what is default modifier? A default modifier is a keyword that you should not be typed in your IDE or in your code. It's just automatically used in Java. For example, you can type a method void my method and the declaration of your method and the code inside that method, and you didn't write what kind of access modifier it has. By default, Java will take it as a default access modifier. Mostly it is an public, but it's a default modifier. You can write public void my method easily. You can also declare your method as a private and protected. Java has also some non-access modifier too. So it means that those modifiers are not used for access purpose. For example, static, final, abstract, synchronized, transient, volatile and so on. It's maybe native. Okay, native. So let's see the modifier element matrix table for Java. So here it is. So firstly, we can see the abstract, final, native, private, protected, public, static, synchronized, transient, volatile and strict FP. So let's talk about those. You can see we have already talked about private, protected and public. So we will talk more about those. You can use private, protected, public method for data field, methods and constructors. For the class, you cannot use private and protected for the outer level. It means you cannot call the variable or the method inside this class which is declared as a private or protected from the other class, which is from the other class, without creating an object of that class. Actually, you can't use those variables which are declared as a private or protected, but you can call those method or variables if those methods are declared as a public. Let's see a code that will make clear about everything. So here is the first code. It has some a method and a variable which is public and protected and a method which is public and protected. Okay, this method and variables can be used from this class but not the outer class. But if those variables are public, let's say public void my method and public int I, you can use those variables from outer class. Okay, that's clear. And for same thing for the interface, you cannot use private and protected from the outer class. You can use from the outer class. You can use from inner class for private, protected, public, all of them. Okay, so we have completed the basic access modifiers. Let's talk about the non-access modifier from the table. In this table, abstract, final, native, static, synchronized, transient, volatile, and strict FP are non-access modifiers. So first, abstract. You can see the data field and the constructor cannot be declared as an abstract, but you can declare a method as an abstract method. Now let's talk about the class. If you can call your class, you can declare your class as an abstract class, and your subclass, which is extending the abstract class, it also can be an abstract class. It is also same for the interface. Your super and sub interface could be defined as an abstract interface. Now, the final. You can declare data field and method as a final, but you cannot declare a constructor as a final. So you can see also you can declare class of super and subclasses as in final, but you cannot declare interface as a final. Native keyword is hardly used in your Java program, but sometimes you need native methods. If you want to import a method or list of method which is written in different platform or language, for example in C, C++, if you want to need those methods to use in your Java program, then you have to declare a method as a native method. So it's an advanced topic. We're not going to discuss about that. Let's talk about static. You can declare method and data field as a static, but you cannot declare constructors as a static. You will see also that class and interface can be declared as a static, but you cannot extend those class which are static, and you cannot implement those class which are static. If your data field is a static, it means that it will allocate a static memory in your hardware, and if your method is a static method, then it will be called when the object of its class is initiated. It means that a class, here is a class, and the method is a static method. It will be called when the object of this class is created. Let's talk about the synchronized keyword. We can see that from the table that you can use the synchronized keyword only before a method. It means that synchronized keyword used to indicate a method can be accessed by only one thread at a time. The synchronized modifier can be applied with any of 4 access level modifiers. So it means that you cannot use the synchronized method twice or more than that at the same time. We are not going to talk about the transient and volatile non-access modifier. Now the strict FP. Now let's talk about the strict FP non-access modifier. Strict FP is a keyword in Java programming language that restricts the floating point calculation to ensure the portability. For example, some application a programmer might need every platform to have precisely the same floating point behavior, even on platforms that could handle greater precision. However, if this level of precision is not necessary, the virtual machine doesn't use intermediate by default. You can see that a method, class, and interface could be a strict FP. From the table, you can see that your method, class, and interface can be declared as a strict FP. It means that if your method is declared as a strict FP, then inside your method, if there is some calculation of the floating point, it will maintain precisely the same format, universal for the all platform, and same for the interface and the class. If your class and interface is declared as a strict FP, and so it will work like inside your class, all code inside your class, if there is any floating point calculation, it will maintain the platform independent precision for this segment of codes. Now let's talk about some rules for the modifiers in Java, a method declaration can contain only one of the access modifiers. It means if you declared a method public void my method, you cannot declare public private void my method. It's like that. Class cannot be declared as an abstract and final simultaneously. It means that you cannot declare your class abstract and also final at the same time. Now, abstract method cannot be declared private, static, final, native, strict FP or synchronized. It means that if you declare your method as an abstract method, you cannot declare it as a private, static, final, native, and so on at the same time. Method cannot be declared native and strict FP simultaneously. It means that you cannot declare a method which is native and also strict FP. Abstract method and native methods have no body. It means that you can see here abstract void method and native void method. So means the declaration of the method is here, but the body of the method, you can see that abstract void method and native void method. It means that the declaration of the method is here, but the body of the method will be declared elsewhere. A class that contains abstract methods must be declared abstract. So it means if a class contains an abstract method inside it, then the class must be declared as an abstract class. And the last one is final field cannot be volatile. So we are not gonna talk about the volatile, so we are going to skip that part. In next two tutorials we are going to see the access modifier and the non-access modifier codes and the implementation of those modifiers. Thank you.